few presentations that we're going to do today and on Friday that I really enjoy doing, and I hope you all will enjoy it as well. So the idea for the presentations that we're going to see today is basically we're not going to get a lot of hands-on work on data, but what we're going to discuss is how do we prepare to start working with data. So what kind of a mindset do we need to have, and what are the questions that we need to ask ourselves ahead of time so that by the time data work starts, we know what we want to do and we know how to get there. So I am going to include a few examples of data sets that I hope will be relevant for you and that I hope are similar to the kind of data sets that you work with in a day-to-day basis, but we can always use one of your examples. So when we get there and I start opening data to ask you questions about it, feel free to suggest looking at some data that you already have in your hands. And also it would be good as we go through the examples, and there are a few exercises at the end of the lecture. I want each of you to pick a project that you're working on and that you're planning to use data for that we can apply this to. Ideally, a project that you have already received some data, so you know kind of what the initial set of information that you have to work from, so that we can make a plan for how to use that. Feel free to stop me and ask questions as I go. You can either unmute yourselves. I think you should be able to unmute yourselves, or just send the questions on the chat. I will have them. I have the chat open here. Okay. I think you can see my screen now, right?
Yes.
Great. Okay. So the first presentation I'm gonna take you through is what we call Introduction to Statistical Programming. And these are basically some motivation and initial mind setting for us to think about data. This is the very first presentation that we make for anyone who's joining our team and will be working with data in one of DIME projects. So there's a few different ways to work with data. There's a lot of different software that are available for you to work on. The one that's most commonly used and possibly the most user-friendly is Excel. And what we use in our department are what we call statistical programming software, or statistical programming languages. And I want to explain to you what are the difference between these two, and hopefully get you all interested in learning a little bit about coding for statistical analysis. So whenever we are looking at Excel, what we do is that we open a spreadsheet that contains data, and then we can manipulate that data by making changes to it or by using it in formulas and exploring that data. Whenever we are using a programming language or another a code-focused statistical software, what we are doing is that we are writing instructions for what needs to be done to some data. So we will receive the data just like we do in Excel, but the difference is that we cannot make changes directly to that data. What we do is we write down the steps of how to prepare, analyze, and visualize that data. You can think of this as being the difference between writing a recipe and making a meal. So I don't know if any of you are cooks and enjoy cooking. My husband is a very good cook. He's great with intuition. He just puts things together and he, gets whatever is on the kitchen and turns it into something delicious. And that works very well for him. It doesn't for me. I am pretty much a robot in the kitchen, which is why I only bake. Because I need very precise instructions, and then I can follow those instructions, and I can, get something decent out of that. So the problem with just, cooking out of your own mind and using your intuition is that if you ever want to do that again, you may not be able to recreate exactly what you have done in the past. So what we are trying to do here is to get you to think about how many times you are going to analyze similar data and how you may want to change it in the future. If you have data that will be coming in regularly, so for example, let's say you are receiving data every quarter and you need to create a report to inform how the performance of your unit has been on that quarter. You should create the same report over and over again. So it is easier to have a predefined set of instructions that can be applied every time that you receive new data, whatever kind of data you are receiving, than to do it from scratch every time without remembering exactly what you did before. So that means that you will be able to recreate the same output with different inputs that you receive over time. And if you want to try and do something slightly different, then you can change only parts of it and still keep the memory of what you had done before. So this is what we do when we use code. We are writing down all the steps that we took to create some output, as opposed to just creating it without creating a record of what we have done before. And more importantly, we are not making changes to the original data that we received. So if we want to go back to the very first set of data that we had, we can do that. I think I've already covered everything that's in this slide. Oh yeah, so the other thing that is important to keep in mind is that whenever we are writing these recipes or these instructions for how to analyze data, we need to know that both us, when reading this recipe in the future, and other people should be able to understand it. So for example, if you write on a recipe, use that green leaf that looks like a star, it's very possible that I will not understand it in the future and other people will not know what I'm talking about. So it's important to be very clear in our instructions, both when we're talking about recipes and when we're talking about code. We need to make sure that we are creating instructions that other people will be able to follow in the future. Question so far? Does this argument make sense for everyone? The next thing that I'm going to start talking about is what are the different ingredients or the different inputs that we take to create our data analysis. Okay, so I'm gonna move ahead. So when we're talking about data analysis, there's a lot of different ways that data can come in and that we can receive it. So for example, what we call data can be images, it can be a set of texts, it can be satellite imagery, it can be any kind of very complex information. But the most common format that we receive data is what we call tabular data, or a table. So I'm gonna introduce some concepts here that explain what a table is. And this may seem like I'm overcomplicating something that everyone understands, but as you will see, there is a reason for me to be introducing this concept. So tabular data is data that is organized into rows and columns. And you can think here, when I'm talking about tabular data, you can think of an Excel form. The best way to organize tabular data so that we can understand it and then so that we can easily read it is that each row in a table will describe one individual or one observation or one member of a class. And we'll talk more about what one observation means. And then each column in this data table is going to represent a piece of information about the individuals that are being described in each row. So each row should contain exactly the same number of cells so that we know that they are talking about each of these characteristics that are represented in columns, although it's possible that these cells are empty. For example, if we were filling in some information about everyone in this class, we could have a table where the rows represent Abhishek, Mantasha, Mavis, Aisha, Solomon, Luiza. And then we could have columns that say, for example, where we work, what is our age, where we are joining this meeting from. So we would have that information from each of us, and each of these pieces of information would be stored in one column. But someone could say, I would rather not say how old I am. And in that case, we would have an empty cell for that column on the row that represents that person. I know this sounds like a very complicated way to describe a table, but we will see why we are describing it like that. So here's an example that is very similar to what I was just describing. So we have a number of different people. This I put together for a training that we did in Croatia. And I meant to have people that could be recognized in this table. But basically what we have here is that we have rows that represent one person each, and then we have all the same information about all these people. And then you can see that each column here is consistent. So I don't have, woman on the same column as I store age, and that is very important as we handle our data in statistical software. So we call all of this here, this table that we have here is called a data table. And each cell in this data table, meaning this one here, or this one here, this is called a data point. This is a piece of information about one particular person. What is being represented here in a column is what we call a variable, which means this is, a set of information that is always representing the same characteristic of the people that I am showing you information for. And then what is represented by one row here is what we call an observation, which is the set of all the data points representing one individual. And in this case here, I have only one data table, but I could have more. And if I had more, then I would have a data set that has multiple data tables. But I can also call one single data table, I can also call that a data set. So whenever we are receiving new data, we want to look at it and try to understand what kind of information that it contains. So there's two things that are very important that we want to identify as soon as we receive some data so that we can understand it. It should be easy to identify what is the unit of observation and what is the variable in this data set that uniquely and fully identifies the observations. For example, if I receive this data set that I have here, so as you can see, we have a few different rows and the variables are officer ID, village ID, district ID, name, and age. I'm going to ask myself, what is the unit of observation in this data set? So who can tell me what unit of observation is being represented here? What am I showing information about? Daniel, you are going to answer the question?
You are showing information about the age of the people or the units of observation. So age is one. Then there are various IDs. Village, district, and then their officer ID. Thank you.
Correct. Thank you. That is right. So I have here, so age is one of the variables that I am including in this table. It's one of the pieces of information that I have that I'm giving whoever is reading this table. And what we call the unit of observation is basically what is represented in this row. So what is this age about? This age is about people. And these people in this case are officers of some sort of organization. So when we talk about unit of observation, what we are asking is, what does each row in this data set represent? So in this case, each row represents one officer in a department. And then when we talk about a unique and fully identifying ID variable, and we'll see this later on, yes. When we talk about a uniquely and fully identifying variable, we are talking about a piece of information that allows us to always identify each observation uniquely. So let me skip to this here. An ID variable is something that helps us communicate to other people which observation we are talking about. So it must have two characteristics to be a useful ID variable. The first one is that it needs to be uniquely identifying. I'm gonna take a quick look at the participants list here to see if I can come up with an example. So for example, and this is not a perfect example, but if I were to use our names as an identifying variable, and I said that I want to ask a question to Emmanuel. This information is not without, it is not enough to uniquely identify who I am trying to refer to. And I know this is not a perfect example because the two Emmanuels that are listed in my participants list have slightly different spellings. But if I just said, if I just referred to Emmanuel, you wouldn't know to which Emmanuel I'm using. So in the case of our list of participants here, the name is not uniquely identifying. So to be uniquely identifying, a piece of information must never be repeated for two different observations. And the other thing that we need an ID variable to be is that we need it to be fully identified. So that means that I can never have this information missing for any of my observations. Otherwise, I cannot refer to all of my observations using an ID variable. So as Daniel mentioned, we have in this data set here, we have three different IDs. We have officer ID, we have village ID, and we have district ID. Which of these is uniquely and fully identifying? Which of these can I use to refer to an observation and you will know exactly who I am talking about? Yes, I see three hands raised. Daniel, since you already answered one question, let's go with Aisha.
So I think it's the officer's ID.
Yes, exactly. Why do you think that? Why is village ID not an identifying variable?
That one also is a variable, as you said, but the officer's ID is a unique, which differentiates one officer from another, because it's unique in a sense that no any other officer can use that same ID, even if the person is coming from the same village as you.
Exactly. That's very good. Thank you. So the village ID and the district ID have duplicated answers, right? So if I said, I want to know how old is the observation that has village ID 32 here, then you wouldn't know which of the two I mean, right? So it could be the office, it could be Charles, or it could be Jeffrey. So it is not, there's some room for error if it's not very precise information. Okay, so in this table here, we are having information about people. Each observation is representing one person, and the unique ID is the officer ID. How about this one? And this, I see that this example does not necessarily okay, yeah, I remember now what I wanted to ask about this. What is the unit of observation in this data set? What is each row representing? This is the easy part of this table, is telling what it represents. So when I say here age, what is this age referring to? Is it referring to the clinic? Is it referring to the district? Is it referring to the patient?
It is referring to the patient.
Yes, thank you. So each row in this table represents one patient. Oops. And each patient is linked to a clinic. So what is the unique and fully identifying variable in this data table? It is a trick question. Yes, Daniel?
Yes, the unique data as presented is the clinic ID.
Is the clinic ID. Okay, let's look at what we need to have a unique and fully identifying variable. The first thing that we need is for it to be uniquely identifying, which means that it only occurs once in a data table. Does clinic ID satisfy this condition?
No, it doesn't.
Right. So, and it was a tricky question. Sorry, I see someone else has their hand raised. Prince.
Hello, can you hear me? Good afternoon.
Good afternoon.
Yes. Could it be the name? The patient name?
Yes. So in the way that we see it here, the name could be the uniquely identifying variable because it doesn't know it is always present. So the two characteristics that we were looking for is that it is never missing, so it's never blank, and it is never repeated. So in this case, it could be. However,
it can also be the age.
It can, yes. It can also be the age.
Yeah, so I think I also go with the patient's name and the patient's age.
Yes, that's very good. So let's say that I wanted to keep increasing these records and I wanted to keep adding more patients and more clinics to it. Is it likely that age and patient name would still be uniquely identifying after I added 1,000 observations to it?
No.
Yes, you're right. So both patient name and patient age are things that can very likely be duplicated across a data set. So the problem with this data table that I'm showing you here is that as it keeps growing, it would probably become very difficult to uniquely identify an observation. So what we would like to do in this case is to add one more variable that would give us a number that will never be missing and will never be duplicated. So this could be, it doesn't have to be a number, it could be, you know, a code including letters. But this could be things like an ID that is created in the clinic when you enter, when you come in and register for an appointment. It could be your taxpayer number. It could be, you know, a combination of a lot of other different variables. It could be, for example, that you're combining the clinic ID with the district ID, with the patient name, with the patient age, with something else. But in this case, this would not be a sustainable data set for us to keep maintaining over time. Questions so far? Okay, so whenever you receive a new data set, the very first thing that you want to do is you want to understand what is being represented here and how do I refer to the unit that is being represented here uniquely. If you receive a data set that does not have a unique identifier, then the very first thing that you want to do is create one, so that you know exactly about which individual in this data set you are referring whenever you need to. Okay, now we have one more example. Let's see in this case, if you can tell me what the unique identifier is. And also what is being represented here. This is a public procurement data set. So for those of you who are not used to handling public procurement, it may be a little bit difficult to understand. But let's see if we can understand how these observations are organized. What is represented in each row in this table? Aisha, did you want to answer that? Or I see that Prince also has his hand raised.
Yes, so I think the unique, my table is off, I can't see. Oh. Okay, it's back now.
Yeah, sorry,
Hello?
I hit the mouse unintentionally. I think you have it back now, right?
Yes, thank you. So I think the unique identifier variable here is the lot ID.
Correct. Yes.
Yes, because the value of the CD as time goes by can change. You can have the same amount, and then the CPV category 2, we can have the same. You have the same thing, 2 or more, as in the same. Let's say the office furniture, we have the same for another activity as in office furniture, and the producer ID too. We have duplicate numbers. So I think the lot ID is the unique variable here.
Yes,
Thank you.
that's right. Thank you. So basically the way that this data set is organized, it's, like I said, it's a little bit unique to procurement data. So this is basically data that is, let's say you have some part of a government that is trying to buy something. So the CPV category explains what they are trying to buy. And then the way this is organized is that whenever a government unit wants to buy something, they open a public procurement procedure. And in this procedure, they will outline everything that they want to buy. And then for each contract that they make, they will create one lot. So for example, you can see here that we have a few different lots. So each observation in this data set represents one lot of goods that were bought by this public agency. But for example, these 4 lots here were announced as part, oops, how do I do not know how to unselect this. They were announced as part of the same procedure. So they're part of the same group, but we have different information for each of them. So we need to be able to refer to them uniquely. So that's why we have different IDs here. Yes, Sarah, do you have a question?
No, please.
Okay, sorry. Okay. Now, whenever we receive this data, we will receive, let's say, this kind of data here. We have information on the age of the people that work in a certain unit or government agency. We are receiving this data because we want to do something with it, right? The reason why we opened it is because we wanted to extract some sort of information from it. So before we actually start analyzing this data or processing it, we want to think about what is the best way for me to do this. So I need to understand all the data that I have, how it is organized, and how I can explain it to other people. So the reason why we have a unique ID always is that whenever we want to talk to someone else about one particular observation, we need them to know what observation we are talking about. And that is also true about other parts of our project. When we are trying to explain what data set or data table we are talking about, it's important that everyone else understands what particular data table I'm talking about. So if I told you that I want to talk about the clinic data, you would probably know that it's this one. And if I said that I want to talk about the public procurement data, you would know that it's this one. But when we get a lot of data sets together, it's important that we all agree on how to call them so that we understand each other. So in order to facilitate this process, we have developed what we call a template for a data map. So a data map is something that we use to be able to find ourselves inside our data. And as the number of data sets that you're working on start to grow, it becomes particularly important to have this data set, this data map. So you understand what you're doing, you know where you are, where you want to get, and you have a plan to do that. So I'm going to start talking now. I'm going to explain to you what each of these, the different components of a data map are. And then what we're going to do later is that we're going to start creating one from some data set that you want to use. Okay? So the first thing that we need, and if you don't have a project in mind yet, then I can give you a project. I can give you a mock one for you to work on. So the first thing that we need is what we call a data linkage table. So this is a list of all the data sets that you have received. Let's say, for example, that I am dealing with public procurement data. In this case, I will have things like, I have this particular table here that gives me the value and the type of good that was bought on each lot. So this is one data table, but I will probably also have another data table that says for each procedure when the procedure was published. So in that case, I would have a list of 2 data sets on my data linkage table. I will also include what is the unique ID variable in each of my data sets and how they connect to each other. And I will include, a name or a nickname so that when I refer to a particular data set, you know what I'm talking about. Let me show you an example here. Do you see a table with a green header?
Yes, thanks.
Okay, great. Okay, so this table that I'm showing you here, it is showing the complete list of data sets for a project that is very complex. So basically what we did on this project is that we have ran surveys with farmers and with communities, and we ran 3 surveys with each of them. So at the end of it, we had, a long list of data sets that were included. So we are listing here. So we have a baseline survey about prices that was created at the community level. So for each community, we will have one observation in this data set saying what's the price of different items in that community. And then we have a baseline survey that we did with farmers. And then, so for each farmer that we have, we are gonna ask them how much they planted and how much they harvested of different crops. And then we do the same again for a midline survey for prices and farmers, and then again for an endline survey with prices and farmers. So you can see here that I have written down for each of these, what is the unit of observation, what is the ID, the unique identifier for this unit of observation. So whenever the unit of observation is a community, the unique identifier is called COM-ID or community ID. And whenever the unit of observation is a farmer, the unique identifier is HHID or household ID. The other thing that I have included here is how these ID that I have in my observations relate to the other IDs in the other data tables in my data set. So for each community ID, I will have multiple household IDs, so many household IDs to one community ID, because I can have many farmers that are part of the same community. So if I need to connect information from a community data set with a farmer data set, I know that for each community, I will have many farmers and that I will use the community ID in the farmer level data to connect these two. And the other way around as well. So on the farmer level data set, I will have one unique household ID for each farmer. And for each household ID, I will be able to connect many community IDs. So what I am doing here is I'm saying I will have different units of observation in my data set, but I should be able to connect them. So I should be able to tell from the household level data set and the community level data set which households are part of which communities. If we had a procurement data set, we would have to connect, let's say, lots to procurement procedures. If we had an HR data set, we would have people working on government agencies, and we would have to connect each person to one agency. And then the other information that I have here is just saying this is where I can find this data, because that is also important, right? It's not enough for me to say, I need you to open the midline for prices if you don't know where it is stored in the computer. So we are also writing that down in our data linkage table. Questions here? Oops, I think I stopped sharing. Sorry. I meant to go back to the other table. I go back. I lost my presentation. Okay, I'm gonna look for it. And in the meantime, do you have any questions? Here it is. Okay, so this is what we call the data linkage table. And as you can see, the whole point of this data linkage table is to make it explicit how the different tables in our data set are connected. Okay. Next up is what we call a master data set. So a master data set is basically a table that includes a list of all the instances of a unit of observation that we have ever found. So let's take the example of, what was it here? Here, this clinic level data. We have a list of clinics, so we will have one master data set that lists all the clinics that we have ever found in our data. And we will list in there any information about this clinic that is not changing over time. This is what we will use to create a unique identifier for a clinic. So for example, I will have there the name of the clinic, the address of the clinic, and the type of appointments that this clinic takes, what kind of doctors are available in this clinic. And I'll use this information to create a unique ID. So this is one unit of observation that I have in this data set. But I also have two other units of observation in this data set. I'm also representing districts. So I need a list of all the districts that I have ever found, all the districts that exist in my country. And I will have a list of patients. So what are all the patients that I have ever encountered in all of the data sets that I have received? So for example, if I receive a list of all the patients that visited one clinic in 1 month, I can then know that this same patient also visited another clinic in another month, because I have a list of all the information about this patient, and I can know that this patient is the same that visited the other clinic on another month. This is why it's important to have a unique ID, because then the unique ID for this patient will be the same on the 2 visits. So this master data set is what we are going to use to make sure that we have unique identifiers for all the observations and all the instances of the unit of observation that we have. I want to see if we have an example here. There's no example. That's fine. Questions about the master data set? Okay. So the last thing that we're going to do, and we're gonna go through each of the steps to doing this in the second half of our lecture today, is we're going to create a data flow chart. What a data flow chart does is that it shows us what is the whole plan for handling this data set. So let's say that I have a list of all the original data sets that I have received, that is in the data linkage table, right? And I know where I want to get. I know, for example, that at the end, I want to produce a report that says the number of women that I have represented in each part of the government. So I'm starting from a lot of different data sets, and what I want to create in the end is one particular indicator. What I'm gonna do is I'm gonna write down all the steps that I need to take to get from my original data to that final indicator. So before I actually start using the data, I will simply draw a plan of how to get from one point to the next. So as you can see, I have talked a lot during this presentation, and we have not created one single piece of indicator or one single graph. We have not calculated a mean. We have not created a bar chart. We have not gotten to that. And the reason for that is that actually doing that, when we are talking about data work, calculating a mean is very simple, in the sense that there is a predefined function in Excel or whatever other statistical software that you want to use that will calculate the mean. It doesn't take a lot of preparation to do that. That is the easy part. The hard part is understanding your data, understanding the data that you are receiving, understanding how it is organized, and understanding what you need to do to get to calculating the mean. So what we are going to do next is that we are gonna write down our plan to calculate whatever indicator we want to create. Okay, and as we do that, I want to remind you that it is very important to trust your instinct about data. And this is something that we will get to both when we calculate an indicator, but also as we first look at a piece of data. Whenever we are looking for some data for the first time, let's say we are looking at this data set here, some things that are important to think about are what does this number mean, and does this information make sense? So do I believe the information that is written here? For example, let's say that I had received a table with HR data that is telling me information about a bunch of public officials. If the part where it says the age of someone said that they are 130 years old, I would be very skeptical about the quality of the data that I have received, right? Very unlikely that someone got to live 130 years and that at age 130, they are still, going to work as a civil servant. This is a very straightforward case where it is easy to identify something wrong with the data set or with a data point. But another thing that we could also, that it would take some more thinking to realize, but that we should also be able to spot is how different information in a data set relate to one another. So if I have two variables, are they consistent among themselves? Let's think of an example. How would we expect the date of birth of a public official and their date of entry to the civil service to be related? That is a question for you all. If you're looking at a data set and you have both the date of birth of a person and the day at which they started working for the government, how would you expect this to be related? I see someone started responding. Yes, Erasmus. Hello? Please go ahead. I'm sorry, Erasmus, I don't hear you very well. So maybe you see if you have a problem with your mic, and I'm gonna go to, okay, PA. Sorry, I don't see your name.
Yeah, the date of birth and then the date of entry into the service will tell you the number of years the officer has to work in the service.
Right. So how would you expect their date of entry to the civil servants to come before or after they were born? Which of them should come first?
It will come after they were born.
Right. And how much after? If I say, if the date of birth said they were born on February 2nd, 2020, and that they joined the civil service at March 3rd, 2022, what would you think of that?
There must be something wrong with the data.
Right. So there's a certain number of years that you expect to have between the two, right?
Right.
So what would be
that will be his education background. He has to attend school, so that one will have to reflect. So he has to take a distance between when he graduates, and when he's entering the service. We have to
What
get
would
that
be
from the
a
data.
what would be a reasonable amount of time? What is the youngest age at which you would expect someone to join the civil service?
That one would depend on what the educational structure of the country will determine.
Okay, so we would look at their date of birth, then how long they studied, and then when they entered the civil service to determine if the information seems consistent.
Yep. Yep.
That is great. Thank you. Elizabeth, did you also want to add something?
Well, yeah, about the age to enter the service. Ideally, you should have completed a senior secondary school. And so we're looking at the maturity age that is around between 17 and 18 years.
Okay, so one thing that we could do when we receive a data set is to test that the person was at least 17 years old when they enter the service. And if they are not, then we want to check what is going wrong.
Exactly.
That is great. So we will see some examples that where we'll have a chance to think about what seems right in a data set. Thank you. Erasmus, do you want to try again and see if we can hear you now? Sorry, still doesn't seem to be working. Okay. So the second part of the content that I want to discuss with you today is exactly how to create a data map. So what we're going to do is we are going to, yes, Sarah, please go ahead.
When we talk about date of appointment in comparison with the age of the officer, we also have to relate it to the time, the kind of policy we being used to recruit, be it the act, the law, or any related regulations that were used to get the person onto the system. Because I remember in some past, some entered into the service at age 16 because of change of policy here and there. Then we have now settled on the 18. But some had entered into the service at age 16 before. So that is also a factor to think about.
Okay, that's great. So what you're saying is that if we were checking the date of birth versus the date of entry to the civil servants, we would have to create different criteria for different dates of entry. So if someone entered before a certain year, they could be 16, but if someone entered after a certain year, they need to be 18. That is great, yeah. Thank you, Sarah. Okay, so what we are going to do now is we are going to create a data map. So I want each of you to think about a data set that you have received or a data set that you will work with in the coming months. And what you need to extract, what information you need to extract from this this data set. And then we're gonna start creating a plan for you to analyze this data. Erasmus, we still cannot hear you. Do you want to write down on the chat what you wanted to add? Okay, so I'm gonna give you, let's see, 5 minutes. Let's take a 5-minute break for everyone to kind of stretch out, and also for you to find in your computer a data set that you have received in the past or that you will be working on in the future, and that we can use for this exercise today. If you do not have one, if you don't have a data set in mind, please raise your hand, and then I'll share one with you that you can use. I'm also gonna go and get some water for myself in the meantime. Okay, I see a few hands raised. Okay, great. I see only 4 hands raised. Does anyone else not have a data set? I think as much as you can, it's ideal that you work with your own data that you're already more familiar with, but I also have one here that I will send you. Okay, so we're gonna use, okay, 5 people who don't have it. Okay, great. We're gonna use a data set, the data set that I'm gonna share with you for examples, and then let's see if I can share a file in here. Doesn't look like it. Okay. Let's see if I can send it to all of you over here. I cannot. Adrian, can I send the file to you to share with everyone?
Sure. Yes, I can try to do that.
Because I cannot see the list of invitees to the meeting.
Oh, yes. Yeah. So I'll email it out to everyone after. Luiza, you send it to me.
Okay. Great, I just sent it. I have one more minute for everyone to stretch before we get started. For those of you who do have a data set, can you tell me on the chat a little bit about the data that you have and what you want to do with it? It could be, for now, we can think of, I have 1 or 2 data sets and I want to calculate one indicator, or I want to create one graph to show one piece of information. And what kind of information you want to display. Okay, I think we can get started. For those of you who asked for a data set, I have sent it to Adrian. You should receive it in the next few minutes. Okay. So, like I mentioned earlier, what we're trying to create now is basically a way to communicate what we want to do with our data. We also call it a shared understanding, or we want to create shared understanding about how our data is structured and what we want to do with it. I always tell people in our department that they should create the data map as early as possible in the project. It's fine to keep updating it as you receive more data or as you think of things that you hadn't thought of before. But it's important to have it from the beginning so everyone in the team understands where they are going and understands what the data looks like and what will be the main challenges as you start analyzing your data. Just to recap a little bit some of the things that we have already discussed earlier today. When we talk about a data table, we are talking about data that is structured into rows and columns. It is also called tabular data set or rectangular data. We often also call it just data, but that is a little bit broad, and we're being a bit more specific about how our data is organized when we call it a data table. When we talk about a variable, we are talking about the collection of all data points that measure the same attribute for each observation. So we are talking about the type of information or the pieces of information that are included in our data table. Then we have an observation, which is the collection of all data points that measure different attributes for one instance of the unit of observation. That is, all the information that relates to one person or one district or one government agency, all the information that refers to this one individual in our data set is what we call an observation. then the unit of observation is the type of individual that we are describing. So in an HR data set, when we have a list of employees, the unit of observation is an employee. When we are talking about all the agencies that exist in a government department, the unit of observation will be the agency. If we have a sales data set, we will probably have each unit of observation will be one sale, that is one operation between a vendor and a buyer. And the unit of observation will vary from one data table to another. And then we have a data set, which is a collection of data. So we can have multiple data tables in a single data set. So one data set can have multiple data tables. One data table will represent one unit of observation. So we can have a data set that includes data on multiple units of observation. Okay, so the first thing that we're going to do is we are going to open a data set and identify the variables it contains, the number of observations it contains, the unit of observation that is being described, and the unique ID in this data set. I'm going to open one of the data sets that we created. One of the data sets that I sent you. And for those of you who have your own data sets, I want you to open your own data sets and then make the same notes on your data set. So look at the same piece of information. Okay, so this, do you see the data on my screen? Or do you still see the presentation?
I see the data. We can see the data now.
Okay, great. Okay, so this is the data that we have. Increase it a little bit, so just to make sure that you have everything. So as you can see, this first line here is describing the information. And then each row is representing one unit of observation. And I'm going to start writing down the information that you tell me so that we can remember what we are doing. So the name of this file is HR dataset v9. What is the unit of observation in this data set? What does each observation represent? What is represented by one row? Who can tell me what is represented in one row. Is it a government agency? Is it a public procurement procedure? Yes, a journal. No one has a guess? Okay. So each row in this data set, yes, go ahead, please. Lolo, you were gonna start speaking and I interrupted you. Sorry.
But in the first column we have the employee name followed by the employee number.
Right, and that makes you believe that this is representing what?
The employee name is representing the various unique individuals. Then
exactly.
Each employee has got a unique number, just like we are having in the civil service. We all have staff numbers. That is different from each person's staff number. I have my personal staff number. Danny has his own. Elizabeth has her own staff number, which is so different, which is unique to us.
Perfect. That's exactly it. So basically what we are representing, so the unit of observation is, sorry, the unit of observation is an employee and the unique ID is the employee number. Okay, let's go back to our presentation and see what other information we wanted to see. So how many employees are contained in this data set? And I want you to, and this is for this data set, but you can also do it for yours. How many employees are here? I'm gonna respond that one. Since you don't have the data, I can tell you that we have 310 employees. Yes, Daniel?
Yeah, in fact, I counted 311.
Yeah, we have 311 rows in here.
Yeah, 100.
But the very
then
first one.
The individuals are 310.
Exactly.
Okay.
Because the first row is just the names of the
Yes.
variables.
Yes.
Okay. What is the next question? Is what are the variables that we have here? What information do we have about these employees? Yes, Daniel?
Yes, I have counted 20 variables. Starting from the employee name all the way to date of entry. That's the last one I can see from my.
Okay. Yeah.
Yes.
So there's actually 28 because there's information that is not showing.
Yeah.
So exactly. So basically each column here is one piece of information. So what I want you to do what I'm going to do for this data set, and I also want you to do for your data set, is to start what we call a data dictionary. A data dictionary basically lists all the information about the data set. It will explain what information is contained in the data set. So we have in here the employee name, and then we have the employee number, which is the unique employee ID. Then we have the date of. Basically, what I'm doing here is I'm going to explain what each of these variables represent. And this is a very useful thing to have for any data set that you are receiving, because this will allow you to quickly see what information you have available in your data set. So for any data set that you receive, you should ask for a data dictionary as well. If you don't have if they don't share a data dictionary with it, then you should also put together one as soon as you can. So basically what I'm doing is I'm adding some explanation on what this data contains. What else do we have here? The performance score, I think, goes from 0 to 10. And I'm going to assume that 0 is the lowest and 10 is the highest. So I'm going to write here 0 lowest, 10 is highest. So this is just, I'm just adding some information for you to see how we usually create a data set, a data dictionary. I'm not going to create all of it right now. I'm just trying to give you some examples. So you see here that we have some categorical variables as well. So for example, we have something here that is called married ID. And that means that this is a way to translate the marriage status into a number. That means that if this is 1, the person is married, and if it's 0, then the person is not married. So I'm going to write it here. In general, 1 will always mean yes, and 0 will mean false, unless it's clearly stated otherwise. And then there's another one here that is also that also says it's an ID, and that means that this is a categorical version of the gender variable. So you see here, this is sex, and this is gender. And basically what we see here is that whenever gender ID is 0, then the sex is female, and whenever the gender ID is 1, the sex is male. So I'm going to add this information here. Let's see if there's any other information that needs some explanation. I don't.
With the gender identification, if 0 to women and 1 to men, won't the women be saying that we are discriminating?
Yes, I agree. I really don't like the fact that so actually this is not the ideal way to represent this kind of category. In general, you would have you would not start with 0. You would start with 1 for categories, and you'd only use 0 for things that mean no. But in this data set in particular, they decided to code it like this. I think it's not very good.
Okay.
But also in general, what happens when you turn categorical variables into numbers is that the lowest number will be the one that is first on the alphabetical order. So because female starts with F that comes before M, then female is assigned the lowest number. Okay.
Okay, that is good.
Yeah, so that is a way to be more objective, I guess. It's not just a matter of assigning importance. It's alphabetical order. Yes, Mavis. Oh, sorry. I think Mavis and Abraham have their hands up from when they were asking for the data set. Okay. So in here, what I have done is I have created a list of all the information that is contained in my data set. So this is a way to quickly inform other people about what I have in my data and what information they can see. So this is a very useful thing for you to have whenever you receive data, and also for you to create whenever you are generating data. Let's go to the next exercise. So the next thing that we are going to do is we are going to list all the different original data sets that we received in our project. What we're going to do is we're going to create a data linkage table with it. So I already started this list, and I have already added one observation to my list, which is the data set that we have just looked at. But in the data set that Adrian just shared with you, we also have 2 more data tables. So let's look at them. We have one that's called recruiting costs. And we have one that is called a salary grid. Okay, so let's go back to our questions. Let's look at the recruiting costs. The recruiting costs are here. What is the unit of observation here? What is represented in each line? Remember that the name of the table is recruiting costs. So this gives you some information about the content of it. I know this one is a little bit tricky, so I can fill it up. What this is showing is that it is showing each row represents one source of costs. So and then the unique ID or the variable, the column that is uniquely identifying the observations is the employment source. And we have, in this case, 22 observations. Okay, now let's see what other information we want to include in here. The first one says, oh, sorry, we have another data table as well, which is the salary grid. So the salary grid is giving us the salary for each of the positions. So each line or the unit of observation is one position. The name of the unique ID is called, the unique ID is this, which is the name of the position. I'm gonna write this here. And we have a total of 12 positions listed in this data set. Now, the important part about the data linkage table is how we can connect one of these tables to the other one. So based on the information that we have about these, how can we connect this, these tables? Can we connect the salary grid information to the HR dataset information? I'm going to show you both of them here. So this is the salary grid, and here is a list of all the variables that we have in the HR dataset. Do they have a variable in common that we can use to connect a person to the salary that they should be making? I'm gonna give you a hint. There is a way to connect them. Yes. How, Daniel?
Yes, we have position. So we have position here and we also have position there. So yes. So these are two, these the same or common variables that can be used in further analysis.
Yes, that is great.
So position will be important.
And how do we expect these to be connected? Do we expect there to be many people to one position, or do we expect there to be many positions to one people?
No, we are likely to rather have many people to one position.
Yes.
That is more than one people having the same position.
Correct.
rather
We
than
have
the vice versa.
Yes, so whenever we are combining these two data sets, we'll probably have one position connected to many people so that many people should have more or less the same salary. So this is how we will connect them. And how about the recruiting costs? Can we connect the recruiting costs table to any of the other data sets? Let me see if I can open all of them at the same time. So do we have a common variable between recruiting costs and the list of employees that we can use to combine the two?
Yes. Hello.
Yes, go ahead.
Yes,
Daniel.
hello. Yes, I can also see employee source.
Correct.
And so once we have the employee source and we have that table containing information about the different sources, employment source, sorry, then we can also combine that. Thank you.
Thank you. So again, how do we expect these to be related? Do we expect one person to be connected to many what was it? Employment sources? Employee source, sorry. So do we expect many people to have found a job through the same source, or do we expect one source, one person to, sorry, I don't even understand what I'm trying to say. Do we expect many people to have come from the same source, or do we expect one person to have come from many different sources?
Okay, we can expect many people to come from the same source, because once we throw the advert, different people from different locations may pick it and respond to it. So they may come from different sources.
Yes, that's right. So so the way we're going to be able to connect this is that for each person in our data set, they're going to say from which of these sources they came from. And then we are going to be able to tell, for example, how many people were hired through one source. So out of all of these different sources, which one has brought in the most people?
Yes, because
So,
they can be a recruitment agency. Hello.
Yes, I hear you. Please go ahead.
As we were saying, they can be a recruitment agency that bring many people from one source. So as you were saying, is where we can have many people from one source and many people from different sources as well too.
Yes, thank you. That is right. So we are going to use this later we can use this information later to create some interesting indicators to guide our employee recruitment strategy. Okay, so we have only 6 more minutes, and I want to go back to the presentation. So basically what we have done for now is we have created a data dictionary for our main data set. And we have created a data linkage table that shows us how the 3 different data sets, the 3 different data tables in our data set are connected. What we are going to do on Friday when we meet again is that we are going to make a plan for how we can use this information to then analyze the data. Before we wrap up, I just want to have some time for you to ask questions, especially those of you who are using your own data sets. If you had any questions about how to fill in or how to answer these questions. But also we can take questions about anything that you like. No questions? Everything was super clear? I will ask those of you who are using this HR dataset that we shared to take a quick look at the data then and think about what kind of information that would be interesting for us to extract, what information we can analyze from this data set so we can start filling our data flow chart. But that's so if you can think about this and bring some suggestions for Friday, that would be great. Daniel, you had a comment or a question?
No, I am okay. My data was similar to the one you projected. It's a staff list that contains almost the key variables that you had: name, staff ID, age, date of first appointment, last promotion dates, educational qualification, current position. So mine was okay, almost similar to what you presented or projected.
That's great. And do you have some ideas about what kind of information or what kind of indicators you want to see out of this data that you have?
Yes. For instance, it will be interesting to link the age with the current position to see, to give us an idea about how many years people have to have left to serve in the civil service. So if a lot of the people are in managerial positions, or let's say directors, Are they within their 40s, 50s, or about to exit? For instance, to be interesting. Again, we would like to know educational qualification and then position. So how many people are occupying senior positions, for instance, let's say PhDs? How many people are occupying positions, senior positions with master's degree, and so on and so forth? These are some interesting analysis that can be done for decision making.
Great. Exciting. We'll talk about this on Friday. And Jane, you also had a comment or a question? Jane? I guess not. Okay, then, so this is it for today. We're just in time. We'll keep talking on Friday about how to make this plan to analyze our data.